In this question we are given that x is a positive integer. So we have that x is greater than 0. We have to check if x is a prime or not. Now let's move on to step 2 and analyze the statement 1. So the statement 1 tells us that 3x plus 1 is a prime number. Now this will be an odd prime. That means that the value of 3x should be even. This can happen when we substitute even values for x. Now there are two possibilities. The first possibility is when we substitute x is equal to 2. In this case, the value of 3x plus 1 will be equal to 3 times 2 plus 1, which is equal to 7. And we know that 7 is a prime. Also, 2 is also a prime number. In this case, we can say that if 3x plus 1 is prime, then x is also prime. But there is a possibility that when we substitute the value of x as 6, 3x plus 1 will be equal to 3 times 6 plus 1, which is equal to 19, which is also a prime. But we can see that the value of x here is not prime. So we get two contradictory answers and we conclude that statement 1 is insufficient. And from the given options, we eliminate options A and D. We now check the sufficiency of statement 2, which tells us that 5x plus 1 is a prime number. Using similar arguments, we can say that 5x plus 1 will be an odd prime. So 5x has to be even. Following the steps statement that we did in statement 1, we have two cases here as well. So when x is equal to 2, the value of 5x plus 1 will be equal to 5 times 2 plus 1, which is equal to 11, which is a prime number. And we know that 2 is also a prime. Similarly, when we substitute the value of x equal to 6, 5x plus 1 will give us 5 times 6 plus 1, which is equal to 31, which is also a prime number, but we know that 6 is not prime. We get an inconclusive answer and we can say that statement 2 is also insufficient. We now check if both the statements together are sufficient or not in step 3. So from statement 1 we have that when x is equal to 2, which is a prime, the value of 3x plus 1 is also prime. And when x is equal to 2, which is not a prime, the value of 3x plus 1 is also prime. Similarly, from statement 2, we concluded that when x was 2, which is a prime number, the value of 5x plus 1 was also prime. But when the value of x is equal to 2, which was not a prime, the value of 5x plus 1 was a prime number. Combining these, we still do not arrive at a conclusion if x is a prime or not. So we say that statement 2 and 1 are together insufficient. Hence the correct answer is option E.